Okay, question 4. We've got a discrete random variable and we're given its probability distribution, and we're given it in the form of a formula, not a table. So before we even bother doing anything, I think we're going to make a table. So we've got x values and they go from -2 to 3. Let's just put some lines in here. Just draw up a little table. And we've got some probabilities, and we're asked to show that k equals 3/40. So if I put the probabilities in here, the formula is k times the modulus of x, which means forget whether or not it's negative, just make it positive, plus 0.02. So when x is 2, we've got 2k plus 0.02. When k is 1, we've got 1k plus 0.02. When k is 0, we've got 0.02. When k is 1, we've got the same as -1, so it's symmetrical up to now. When k is 2, we've got 2k plus 0.02. And when x is 3, we've got 6k, sorry, I think I'm getting my k's and my x's mixed up. And all of those probabilities add up to 1. So how many k's have we got? 2, 3, 4, 5, 6, 12k plus all these 0.02s, 1, 2, 3, 4, 5, well 5 lots of 0.02. I'm going to do that on the calculator because I'm paranoid. That's 0.1. So all of those add up to 1, and if you don't write that equation down, you're going to miss a mark. So k then is 1 minus 0.1, which is 0.9, divided by 12, which is 3/40, as they asked us to verify. And if you're not convinced by that, you can always do it on your calculator and get it as a fraction. Actually, it's handy to know that it's 0.075. Okay, now before I go any further, I'm actually going to put those values in here. So we've got 2 lots of 0.075 plus 0.02. It's 0.17, that's this one, but it's also this one. These two are the same. And then we've got 0.075 plus 0.02 is 0.095. And that's this one and this one. This one is just 0.02, and this one is 6 lots of k. So it's 6 lots of 0.075, 0.45. And I'm just going to check that they all add up to 1, because if they don't, we're in trouble, but they do, so that's great. Okay, so now we're in a position to do B, which is E of x and the standard deviation of x. Okay, so E of x is the sum of x times its corresponding probability. So we've got, well, actually I'm going to make life a bit easier here. We've got minus 2 times 0.17, but then we've got 2 times 0.17. They're going to cancel each other out. Then we've got minus 1 plus 0.095 plus 1 times 0.095. They're going to cancel each other out. Then we've got 0 times 0.02, well that's nothing. So in the end, the only thing that actually is going to contribute anything is 3 times 0.45. Which is 1.35. 2 decimal places, that's good. Now to find the standard deviation, again we're going to use this formula that the variance of x is e of x squared minus e of x all squared. So we need e of x squared. So we're going to square each x value and multiply it by its corresponding probability. So minus 2 squared is 4. So we've got 4 times 0.17 plus minus 1 squared is 1 times 0.095 plus 0 squared is 0 times anything is 0, so I can ignore that, plus 1 times 0.95, well, there's another one of those, and then we've got 2 squared is 4 times 0.17, another one of those, plus 3 squared 9 times 0.45, and when we all add all that up we get 4 times 0.17 plus another 4 times 0.17 plus 1 times 0.095 plus another 1 times 0.095 plus 9 times 0.45. And obviously there are a few shortcuts there that I could have taken that I didn't, just to keep it clear, and we get 5.6. So the variance of x, I don't need to write the formula down again, I've already written it once, 5.6 minus e of x squared, 1.35 squared. So we get 5.6 minus 1.35 squared is 3.7775. But the question is, what is the standard deviation of x to 2 decimal places? So the standard deviation is the square root of that, which is 1.9435, which to 2 decimal places is 1.94. Excellent. Good. That's A and B done. So C. Mean and variance of a linear function. So I'm just going to remind myself, e of ax plus b is a times e of x plus b. We used that in the didgeridoo question, but we didn't actually write it down. But we did write this down. Okay, so e is -3 and b is 5 in this case, so e of 5 minus 3x is -3 times 1.35 plus 5, which is 0.95. And the variance of 5 minus 3x is simply 9 times 3.7775. And we get 33.9975, which I think I'm going to give to 3 significant figures, 34.0. And lastly, D, find the probability that x equals 3 given that x equals 0. In other words, find the probability that we land on this one given that we're greater than 0, given that we're definitely in here. Well, intuitively, that's simply how much of this whole section is 0.45. Although I could do it in terms of the probability of A given B, which is, as you have to remember, the probability of A and B divided by the probability of B. And either way, you're going to get the same thing. The probability that x is 3 and x is 0 is simply this, 0.45. And the given bit is, given that it's greater than 0, well, the chances of it being greater than 0 is these three added up together. So it's 0.45 plus 0.17 plus 0.095. And I can do that using the fraction button on the calculator. And I get 0.629, again to 3 significant figures. So that question could have been nasty, but using the table and using our brain, we sorted it out. I want to move on time-wise, so I'm not going to show the marks for that one because otherwise we're going to run out of time.